In this section, we are going to continue our discussion on privacy. IoT expected to generate large volumes of data, especially types of data that we would not be able to capture otherwise in mobile or web or desktop application domains. Because IoT devices have sensors which can capture information in a non-invasive way without any explicit action from the end users. So it is easy to collect data from IoT devices because users don't have to do anything. And also because of the advancement of sensing technology, there are different types of data you can capture from each IoT device. And because IoT is new, we have very little idea about how far these data types can be used to identify personal information. For example, if you look at temperature, it could be viewed as a very innocent data type, which could not lead to violate privacy. But nobody knows until somebody use certain algorithms to derive insights. For example, temperature has been used to determine whether you are at home or not. This could be within a home environment, or this could be in office environment, like even within cubicles or rooms. Because of the temperature fluctuations, people can infer and predict your behavior patterns or the past behavior patterns and so on. So that is the temperature alone. So when you combine these different data items, even we look them as very innocent, and even we don't think that they would potentially violate privacy, they could. It's a matter of time someone come up with a different algorithm or way to correlate or combine the data together to derive personal information. At the same time, IoT has the ability to bring a lot of advantages or benefits for individuals as well as for the society as a whole. For example, bring the convenient, or it could be improving the efficiency of the existing systems like energy management. So at the end of the day, IoT seems like a double-edged sword, which you need to manage carefully and have the trade-off between benefits and the privacy risks. Now we are going to look at the definitions of privacy. However, privacy is quite a vague term compared to the security, and more often it is difficult to exactly define privacy. So each of the domain, for example, legal domain or computer science or any other domains, have kind of their own interpretations of privacy. Here I have listed a couple of ways that people have used to define privacy. First one is that privacy is the ability of an individual or a group to seclude themselves or the information about themselves and thereby express themselves selectively. Probably, as you can see, it doesn't help much about thinking about how to implement systems. But it will give you a very vague idea what privacy means. The other definition seems to be saying that the right of people to choose freely under what circumstances and to what extent they will reveal themselves, their attitude and their behaviors to others. This is somewhat helpful than the previous one, I guess, when it comes to thinking about implementation or IoT systems. At the same time, we need to understand that data privacy and data security are two different things. So security could be considered as the broad umbrella where the privacy sits in. However, there are certain ideas and concepts that are only relevant to privacy, and there are certain ideas and concepts only related to data security. And there's somewhat a substantial overlap as well. So in data privacy, we are trying to comply with the data protection rules and regulation and focus on how to collect, process, share, and archive and delete data. In data security, what we're looking at is to take measures to prevent any third parties or unauthorized access to the data or the systems. Depending on the data types you collect, depending on the domain you are in, a potential security breach could violate privacy as well. However, it is subject to the type of data that you're holding, because if you're completely collecting some information has nothing to do with privacy, for example, wildlife data, which has no connectivity to individuals, then probably you are looking at a security breach. Because if someone find out where the endangered animals are, if the malicious parties, they could go to a particular location and hunt down that particular type of animal, which is bad, which is a security breach if you are managing a park or a larger wildlife conservative program. But it doesn't comes under privacy, because it is nothing to do with privacy. Here I'm going to reiterate a story that I already talked about earlier, where the large supermarket chains have identified or recognized a pregnant woman and have done some targeting advertisements before even her father get to know that this young woman is being pregnant. How they do that, it is based on what they buy. So you have more oftenly see that when you're buying online in a supermarket, they will pretty much do the recommendation. So one type of recommendation is that based on what you bought previously. But then other type of recommendation is what other people have bought, which have similar characteristics. So if the supermarket has the data about known data about pregnant women, so then they can profile that, okay, if it is a pregnant woman, these are the products they would potentially buy at the very early stages of the pregnancy. Maybe there could be something they eat, or hygiene products, or any products that they think that could be used to identify these individuals. And then if another person buying the same things, they could pretty much interpret as a pregnancy. So this is very true for any other events as well. For example, people might be able to identify particular diseases. Someone diagnosed with diabetes, perhaps they may be reducing any items with sugar. Because when you have large amount of data, you can profile people, and if you can label the existing data saying, okay, these are the people who have diabetes, and then this is how they change their consumption of food and beverage, you can potentially do the same thing what they did in detecting a pregnant woman. So even though we think that these are very harmless transactions, they have the potential to identify very personal information. Now this is in web domain. So this is the pre-IoT era, I would say, that people trying to infer information about individuals. But once we have these IoT devices, which are much more pervasive and have the capability to track you around the clock, including your sleep patterns, your movement within the house, or the temperature you have set up. So all this information provide much more granular information than online buying. So that is the capability of data science. So sometimes we underestimate what information can be derived by certain data types. So the whole point is that if pregnancy can be detected by just looking at the products people buy, then what could you infer when you have much more granular, much more fine-grained, much more heterogeneous and around-the-clock data that captured by IoT devices. Therefore, if someone have access to IoT data, it could lead to privacy violations much more quicker than traditional web domain. I also talked about this information before about the data and data-driven services, as well as the data types protected by law. So in the first figure, you can see that some of the common services that we use every day, it's not specific to IoT, but some of the domains you can see more and more sensors are now come into play, especially the health domain. There are a lot of wearable devices that has sensors. Mobility, your phones and activity trackers are now able to track your information using sensors. Energy, another domain that has sensors collect a lot of data about individual appliances you use, how long they use. There are a lot of trend in smart plugs, which has the benefit of remotely managing your devices, for example, shutting them off, and also to understand your behavioral patterns and make your recommendations of improving. At the same time, they collect the information which could be potentially used for identifying your personal behaviors and patterns much more granular way. And then the media and communication, increasingly smart TVs has a lot of sensors in them to track you down. So increasingly more and more domains, the ones that listed here as well as many others are now being augmented with IoT sensors which they collect IoT data. In the right hand side we have the illustration which I showed you before in GDPR, which is the European privacy law, which is at the moment considered as the foundation for most of the other privacy laws up and coming. They have two categories. They have personal data and then sensitive personal data. So the personal data is data that can be directly attributed to certain individual, name, location data, identification numbers, IP addresses, cookies, RFID. So they are directly linked to individuals. And then sensitive personal data is something that you need to make extra measures to protect them. So if you are a company or individual or you are building system, IoT system to collect data and process, if you are collecting this information, you need to take extra measures to protect these data. So that is a law says. So it could be like health data, genetic data, biometrics, racial and ethnic data, political opinion, sexual orientation. Number one, first you need to try to avoid collecting these data unless they are essential. If they are essential, you are supposed to make extra care of these particular sensitive data types on how you store and process the data. GDPR, or General Data Protection Regulation, is the law in Europe about protecting data privacy for individuals. It is a regulation that applies to all the countries in European Union, including the businesses that may be outside but do business with the European countries. So if you are developing IoT systems that will be used within the Europe, these laws are applied to your system as well. So initially it was announced in 2016 and then it was implemented in 2018. And there are a number of other laws from Chile, Japan, Brazil, and more importantly, Californian Consumer Privacy Act. All is kind of based on or adopted or variation is adopted based on GDPR. So that is why GDPR is one of the most comprehensive privacy laws in the world. On the right hand side, you can see a visualization about one of the common rights of data subjects. So what are the rights of the individuals? I'm not going to go into the details of each of these laws and how they are, how you need to comply. There's a longer documentation you can look into if you want to Google on GDPR. There are a lot of information about of each of these rights and things you need to do. Some of the basic ones that you need to think about is the right to data portability. So if the subjects want to download the data from your service and take it to the other service, you should be able to, or should allow them to download. I think this is a positive action towards having interoperable IoT systems. For example, if you are producing a smart hub, home hub, which device is connected to, if you are collecting data and all the configuration, people should be able to download them and move into a different ecosystem. How practical this is, it is something to see. It takes time for companies to actually build these things. But at the moment, most of the time, you get to download your data, even though you might not be able to directly transfer per se, because internal systems are not developed that much. Because there is no financial motivation for the companies to implement such level of interoperability. But at least you can download the data about your data and manage them in a way that you like, or even look at it and analyze it by yourself. Then you have right to rectification, which means that you can correct the information about yourself if there are incorrect information within different companies. You have the right to correct them. And then also, if a particular company has there's a breach of data, then you can expect a notification within 72 hours. By law, the company needs to notify you. So you can take either changing username, password, if that is the case, or do whatever is necessary. So you have the right to get a notification. And when you are building the systems, that is something also you need to think about, that if there is a breach, how do you find out the breach, and how do you find out how much the breach is done, what kind of data being exposed, and then within 72 hours you need to tell the people who are affected, as well as you need to report your local authority. For example, if it is UK, then it would be ICO, Information Commission Office. Each country has their own representative authority, so you need to notify them about any breach within 72 hours. So I would like you to pause this video now and go through these individual rights of data subjects and get familiar and think about how the IoT system's development could be affected by that, and what kind of functionalities you might need to implementing to support these rights. As I mentioned before, IoT data could be a risk as well as a blessing as well. Blessing in the sense that you can understand your clients or the stakeholders better and make the decisions better. So you have a lot of flexibility to develop new algorithms and analyze data in such a way that it could bring more convenient or efficiency to the systems. However, when you are collecting data, you need to make sure that you have a proper data management plan. We previously discussed about the sensitive data, especially if you are collecting any information that could reveal such information. You are supposed to take additional measures. And then things become much more complicated if you are collecting medical information or any personal data that could reveal very sensitive information. And you could also be subjected to significant penalties if you fail to protect data or getting the required permission or consent from the users. So getting consent from IoT devices could be challenging, especially if you want to explain them what are the potential consequences and risk, because compared to the traditional web, mobile or desktop application, you don't have a lot of screen space, so you need to depend on the mobile or any other devices that might have screens to get these permissions. And then it could be different, like when you are sitting in front of a computer, then you are focusing on that particular task. However, when the end users are trying to configure something quickly, they might be in a mindset that they don't read everything. So you need to make sure that you put genuinely effort to explain what are the permissions, then requiring what are the data types you are collecting, what kind of information you are trying to extract or derive, and what is the benefit for them, and also give some information about what are the potential privacy risks, so they have the information to make a more informed decision. And in addition to the legal issues, you could also maybe leading to ethical issues. For example, even if analyzing the data could be considered ethical, there could be questions as to whether profiling shoppers using the science of habits formation is ethical. For example, how ethical it is to identify pregnancy without the actual person is openly saying that they are pregnant, and then trying to give potential discounts on products that they would want to buy. Over the next few slides, I would like to take your attention to the ethics issues. Ethics and privacy sometimes go hand in hand. Some of the privacy matters are covered by the laws and regulations, but ethics are something that you leave for individual companies or product manufacturers to deal with. A major data breach could costly for individual companies in terms of fine and their reputation. But also, these breaches could damage the individuals in a significant scale than the company. For example, data on shopping habits or location tracking could reveal the information about where they were in a particular day or time, so they could even lose their jobs based on that kind of data. Therefore, when you are designing IoT systems, you also need to think about the ethical aspect of it. For example, if the data get breached, what are the consequences that individuals might have because of that? For example, if you are a smart TV manufacturer, or if you are trying to understand what kind of TV habits they have, and depending on the time frames that individuals might be watching, that data might be reveal the political opinion about individual. And then if such data get compromised, people might lose their jobs, friends, or any other social interactions just because their personal political views might be not compatible with others. Ethical frameworks for IoT systems are quite new. This is one of the efforts by IEEE standardization process where they look at the autonomous and intelligent systems, and they have come up with 5 general principles to guide the ethical design, development, and implementation. First principle is human rights. So when you are designing a system, you need to think about whether the design as well as the operational systems would both respect the human rights, freedoms, dignity, and cultural diversity. And you also need to think about the entire life cycle of the product, and these principles need to be protected throughout the life cycle. At the same time, you should be able to figure it out. If something goes wrong, you should be able to trace back and find out the cause of the problem. Therefore, transparency is a key design principle when you're designing autonomous and intelligent systems. The next principle is well-being. So well-being has multiple facets, including personal well-being, environmental, and social factors. So you need to make sure that your IoT systems are not negatively and irreversibly harm the individual well-being, environmental well-being, or the social well-beings. So you need to make sure that if it is a IoT energy management system, to make sure that you don't malfunction, or if there is malfunction, there is a backup methods to reduce that or find remedies quickly, because otherwise it will waste energy more than it should. This applies for any other autonomous vehicle or vacuum cleaning devices that would be not doing their proper job. Or you need to think about air quality monitors, which are supposed to advise about air quality to households and individuals. Because if it malfunction, perhaps the end users doesn't know, and then if there are asthma patients or any other patients that are sensitive to air pollution, might not be able to take appropriate action on time because of the device not properly making the recommendations on time. Accountability is another principle. Because of the distributed nature of hardware and software, it might be sometimes difficult to identify who is responsible, and especially if you are having an ecosystem or a larger system that has multiple components connected to it, developed by different parties, it might be quite challenging to find out who is responsible. Whether it is designers, manufacturers, and which manufacturer, or is it whether the owners or whether the operators, or if it is something not functioning properly, maybe it is the internet connectivity, or is there any interferences going on from other signals. So there are so many complex cities around that accountability issue because of the distributed nature, and then the distributed nature of the development. So when you're designing systems, you need to think about how you could enhance the accountability to find out if something goes wrong or if there are malfunction, to understand which component is causing the error. And within that component, what is the accountability? Who is responsible? Whether it's a design issue or is it the operational issue? Whether the owner didn't configure it correctly, or whether it is a manufacturing issue, or whether the owner didn't update it correctly, or updating devices might have changed something. So previously it was okay, but now after the update it is not functioning as expected. So you need to think about combining the transparency and accountability together and offer some features that enables stakeholders or the end users to trace back the accountability and address those issues. Following that up, transparency is of course the next step, which goes hand in hand with accountability. End users should understand what is the system is doing and why. For example, if it is increasing temperature, then users need to have some kind of feedback on why they are doing that. And very early on in some lessons, I talk about working IoT devices as a communities or groups or areas, especially in the context of smart cities, like switching on washing machine during daytime in different time frames to save the load, energy load required from the energy grid. So when this happens, you need to have some kind of feedback given to the end user saying why your washing machine is particularly switched on this particular time, and give some information about the big picture and how it helped the sustainability of the energy grid and reduces the cost for everyone involved. Because if there's no transparency, it might be interpreted as your goodwill is misused by the company, and then you are going through the trouble while other people are maybe doing their washing in the time frames that they need. Because if you are putting these IoT devices together to save the any kind of resources and distributed the workload accordingly, you need to inform the end users what you're exactly doing, on what basis the selections were done, and why the particular machine was on in a particular time. And at the end, how much it saved for you and how much it saved for the community and how much it helped to the entire grid or the country. So these information are quite critical, because otherwise, without any transparency, end users might not be willing to participate in these broader activities that actually delivers the value for not only for individual but for the communities and countries overall. The final principle is awareness of misuse. When you are developing autonomous and intelligent systems, there's always a possibility that someone would hack or someone would misuse your system or game your system in a more casual terms. One of the examples is that Microsoft had a chatbot, which actually it learned from Twitter, but somebody manipulated the tweets in such a way that the bot become a racist. Because if you're using machine learning to learn from other people, and then if the other people in a malicious way manipulate their tweets in a racist way, if the chatbot doesn't know how to distinguish the racism or not, it would think that is the right way, and then it will try to mimic or learn from them. So this is one example, but you can find similar scenarios in every IoT device. There could be ways to misuse them. Misuse could be like sabotage, or it could be security risk, or it could be to do some harm to the system or harm to the stakeholders or the end users around the system. So you need to be aware of these potential misuses and keep track of them, and try to continuously develop technologies to mitigate these issues. So one way to do that is that during the design and the development phase, you need to bring experts from different fields, from law, governments, and standardizations and other domains, to get the ideas to develop mechanisms to mitigate these issues. Smart homes are an application domain within IoT that has a significant impact on privacy. For example, this robot vacuum cleaner has the ability to map your house floor and each room. So you can imagine if that data get exposed, probably the malicious party would know exactly the floor plan of your house without even getting into your house. And then there are devices that constantly listening to your voices to recognize your voice commands. We have seen over the past few years some of these smart speakers are sending the data for the cloud rather than processing on the edge within the home in order to recognize the keyword. So it constantly sending all the data, all the audio data it captures to the cloud. And then you can see there are internet connected beds coming up to the marketplace. Here, this is one of the examples. They say that it's a dual zone. So each of the matrices can configure to different preferences each side. For example, the temperature or any other comfort parameters. This means that increasingly these IoT devices are not tracking behavior of the smart home as a whole, but they are now good enough to recognize the individuals and tracking them separately, which means these data could be used to combine profiles of each individual occupant of the house. In this figure, you can see one of the privacy configuration panels provided by a Fitbit and Activity Tracker. So you can see that it provides some kind of a granular control for the end users to determine with whom they want to share the data. they have some categories of personal information, statistics, and graphs. So what kind of statistics they generate, or the knowledge they generate, and what kind of graph they produce. And then for under each subcategory, they provide granular configuration of data sharing. So who can see the data? So this is a comparatively good example of how the end users should be able to provide configuring their own data sharing approaches. However, it is important to note that these kind of configurations are not easily configurable for non-technical users, especially the communities that are old, who are less technical savvy or understand exactly what these configurations mean. So over time, we should see some kind of profiling mechanism, like depending on what kind of person you are, depending how you look at privacy, or how you believe, what you believe in terms of privacy and data sharing, there will be some kind of pre-built profiles being suggested for individual users. Because, for example, this is only for one device. So imagine if you have 10-20 devices, from a washing machine to the cooker to the energy management systems. This panel could be infinitely long, and then end users will not have the time or the concentration to go through all these configurations and configure them. So we need to develop new mechanisms to understand the user preferences, or at least guess the user preferences, and come up with some default configuration out of the box, and then let the end users to configure any fine-grained configuration if they decide to do so. So it should come with the minimum privacy data sharing configurations, with which shares the minimum amount of data with the cloud as possible. And then to enable more advanced functionalities, if the manufacturer wants certain type of data, then the end user will be asked to manually release that data. So they can take the advantage of advanced analytics, which depends on particular pieces of data. We can see a trend where IoT device manufacturers are increasingly interested in getting access to other IoT devices and share data. For example, Amazon's new voice automated smart assistant is increasingly interested in providing services to other devices, such as switching on and off and controlling other devices through Alexa. But in return, it collects a lot of information about these devices and how people use these devices. Therefore, we increasingly see companies are creating connected data streams. Now, not only they collect data from their own device, but they also collect information and data from the other devices. It is true that these interactions or connectivities between devices add significant value to the end user. It also creates significant privacy risks, because now certain companies or the product manufacturers have access to a large number of data streams in addition to the data streams they get from their own devices. This means now they can not only track when you interact with their own device, they can track your behaviors and activities across your household when you interact with the other devices as well. Smart wearables are another category of IoT devices that has significant impact on privacy. So they are also called smart health or well-being. Most of the wearables start off as activity trackers, and they were expanded into collecting other information that covers broad range of health and well-being concerns. Compared to smart home devices, these wearables tend to collect very similar types of data. In contrast, where smart home devices has a variety of different data can be captured on different activities related to cooking, washing, sleeping, or watching TV. But when we come to wearables, they tend to have a limited number of sensors and limited number of objectives across all these devices. However, because they are so much invasive and they are pretty much wearables, they have very personal and sensitive information captured through the sensors, including information about their health. However, most of the time when it comes to wearables, people do understand the privacy concerns around them because they understand that they collect personal information, their heart rate or stress levels, temperature, and all this kind of information to derive their health and well-being status. Compared to the household appliances, people have very little knowledge about or concern about their privacy. Most of the wearable devices use smart homes, smartphones, or similar devices as the companion device that allows all the configuration or feedback mechanisms are provided through these devices. At the moment, most of these wearable devices use the mobile phones to send the data to the cloud rather than processing the data on the mobile phone itself. This means there's a significant risk of the data being exposed during the transmission or during the processing in the cloud. However, we see that there are a number of programming capabilities, for example, TensorFlow machine learning models that can be deployed in smartphones where data can be actually analyzed within the smartphone itself. However, rarely manufacturers use smartphones to actually do the processing. They typically use the smartphones as a gateway to reach to the internet. Because of the fact that wearable devices are one of the first IoT devices, especially in the consumer marketplace, their applications and systems and privacy configurations are quite matured compared to the other IoT devices. You previously saw one of the configuration panels on Fitbit, which provide a decent level of configuration capability in terms of privacy. Because they are the first one to the market as a profitable IoT product. The other IoT products are still not have reached the same level of the maturity and provide similar privacy configuration capabilities to the end users. In addition to collecting the data that is essential to provide the primary service of health and activity tracking, these wearable devices also encourage the end users to engage with the application and share more data, and especially share data with other end users, creating competitions and comparisons with their friends and family. This means that it also brings the privacy risk of data being exposed through friends. We have seen this whole friends sharing other friends' data or your data getting access through one of your friends in the social media domain. So all the privacy risk we identified in the social media domain becomes valid in IoT devices when you create these kind of gamification or profiling and social engagement within IoT devices and their users and families. So you can see some of the figures here where different users can see each other's data, assuming that it would create some kind of a competition or a motivation to have a healthy lifestyle. The downside is it brings all the privacy risk from traditional social media domain into the IoT domain. Another trend we see is that these IoT devices are used by employers and other companies to create competitions and motivation plans. For example, some of the companies give these wearable devices free of charge by thinking that these devices would help them to change their habits and move into a better lifestyle. By doing so, the employees get better health and they will look after them well. As a result, they will take fewer days off in terms of health matters or in terms of their family's health. So the assumption is that when the employer gives a smart wearable, employee will use it, change their habits, improve their health. Therefore, they will work in a much productive way, as well as they will take fewer leave in terms of health. And then that will pay off the cost of the IoT device and more. And some companies go beyond that and then use these devices and their data to provide health insurance. So the health premium started to vary depending on what kind of habits you have in terms of health and activity. So if you are a very active person, and then if you submit that data to the insurance company, and then they will lower your premium. And if you don't share, it will be much higher. So it creates some kind of a enforcement for the end users or the consumers of the insurance company to share the data. So this creates number of privacy risk because now insurance company has your health data, so they can do whatever they want. Basically, when they get access to that data, they could potentially increase your premium, cancel your premium, or even maybe inform your employer that would impact your job or work life. So these are significant privacy risks which need to be solved by both technology as well as regulation. For example, if someone having a pre-existing condition, these kind of technologies or enforcement will make it difficult for them to get insurance, or the insurance premiums could go high. Even though at the first sight, it may look fair, like if someone is working hard, they are active, then they should be able to submit their data and lower the premium. Sometimes it may seem as a fair deal, but however, the pre-existing conditions and there are other circumstances, people are not being able to follow an active life, not because their fault, but due to some circumstances of the family members. Maybe they are looking after a sick family member, or maybe they are looking after their children or parents. So there could be a lot of reasons why someone would not be able to be active. So if the insurance company start penalizing those communities, then they create a unfair level of discrimination. Here you can see some of the user interfaces of activity tracking and health monitoring applications, some of the information they are able to derive and how they visualize it to the users, and how they create like leaderboards to encourage the engagement. So any of the smart wearable or activity tracking devices usually comes with the application like this. And most of them would collect and generate very similar insights in terms of your health and well-being. This is a concrete example of one of the stories I told you earlier about companies working together to motivate their employees to convert their habits into a healthy lifestyle. So here the Apple and Singapore is using a reward mechanism for Apple Watch users to change their daily habits into a more active lifestyle. So they could, the residents could actually download this Limi Health app and then earn up to 380 Singapore dollars for activities like meditation, walk, and better sleep. There are significant values and also privacy risks on these kind of schemes and encouragement. So the value is for the both for individuals as well as their employers as well as for the country as a whole, because if everyone changes their lifestyle, it would help them to reduce the healthcare cost, which is a significant saving for any country. Because if you look at countries' budgets, healthcare budget is one of the biggest budget in any country. So if you can reduce that healthcare cost, it will help the development of that country for sure. But the downside is when you're collecting this kind of data, it could lead to privacy violations in different levels, for example, individual behaviors and their movements, but also it could lead to intentional and unintentional discrimination. So these kind of activities, even though they have a significant benefit, these need to be monitored and regulated in such a way that these discriminations are avoided and any privacy violations are mitigated. Here you can see some of the user interfaces of the Lumi Health app. This is another level of privacy concern, where this is a small RFID tag which you can embed in yourself to be used as ID card. So probably most of you have used ID card to open the doors or get authentication or getting access to a particular device or a printer or something like that. But of course you may have being in situations where you forgot to bring your ID card. So here you are pretty much embedding the ID card in under your skin. So good thing is you don't forget, but it is quite a privacy invasive product where employees can pretty much track you your movement. So it doesn't necessarily transmitting data directly to the cloud or anything like that. But if you have readers in certain places like the door, the gate, entrance of your employee building, pretty much it can help you to open the doors and things like that. So you can imagine these kind of devices could get abused, because if you have a reader and then be able to read, you can pretty much put a reader in somewhere else as well and then do the tracking and say what are there any employees who are working in this particular place, because that you can read among a large crowd of people. So malicious parties might use this to track you down if they have a RFID reader. So there are a lot of privacy risks. These are like experimentation at the moment by looking at different trade-off of benefits and privacy risk and things like that. But it's worth knowing that these kind of technologies are being developed and trialed. This is another interesting internet-connected device called continuous positive airway pressure. This device helps people to breathe while they sleep. Even though these devices are not mission critical, some of the devices are connected to the internet, which means they not only track how often individuals use them and also how effectively. And there are a number of occasions these devices have shared the information with the insuring companies. One of the main issues around those machines were that the users did not know that what kind of data being collected and how the data being shared with the third parties. So initially, according to in this use case reporting, the user initially become aware of this tracking when they get an email by encouraging them to associate it with the activity tracker. Which means that the data has been perhaps moved around by the company to insurance company to other activity tracking devices manufacturers. However, then the company argued back saying that they only share the information with the insurance where the insurance company provided the device. So it doesn't matter what is exactly what happens. The lesson learned is that these internet connected devices always have the potential to collect the data and also share the data without you telling. So this is both a technical and a legal issue where regulations need to be strengthened, saying that any kind of data sharing should be clearly informed and acquire the consent without having any assumptions that just because the product is funded by insurance company, they have the authority to get access to the data whenever they need. Here I would like to talk about a couple of use cases we discussed already under the lesson number 2 regarding architectures. So edge computing is not only a concept that helps to process more efficiently, it also brings a lot of privacy advantages as well. In this use case, we talk about some of the techniques that you can use to reduce any privacy risks. In this diagram, it shows that you can do sampling, which means that if you are taking large number of frames per second and sending data to the cloud, you could think about sending fewer number of frames, which means less amount of data. And then you can do a blanking, which means that you are not sending parts of the image that are not changing. So because there's no point of, especially if you are looking at people counter or any kind of gender recognition or object recognition, there are parts of the image that you don't need to send unnecessary data, so you can avoid them. You can do blurring. For example, if your job is to count the number of people or track a particular image, you can blur the rest of the image so you don't accidentally send the data to the cloud and then accidentally get the data exposed. So if it is already blurred, then other people cannot extract information even though they maybe get exposed. And also edge computing promotes the idea of processing data on the edge, which is closer to the data source, which is a camera. So if you are doing the processing, at least basic processing like feature extraction and sending only the information or the most critical information to the cloud for further processing, then it reduces the privacy risk as well. For example, if your objective is to find out what are the types of vehicles moving across your shop or any part of the road, you could deploy a machine learning algorithm on the edge to detect the vehicle, and then you can crop it. So you detect it and crop it. Maybe you have seen that there are images that you can put a box around the vehicle, identify it as a vehicle, but maybe you don't have the exact computational capability to detect what is inside the vehicle or what type of vehicle is that, maybe a specific brand or something. But you can deploy a machine learning algorithm that is good enough to detect whether it is a vehicle or not. So once you detect it's a vehicle, then you can send that part of the image to the cloud, and then there will be advanced analytics run on that particular portion of the image, and it will recognize what is inside the vehicle, perhaps how many people are inside, or maybe what is the type of the vehicle or the brand, or maybe even trying to detect whether what is the manufacturing year, and so on and so forth. So the complex part will be happen in the cloud, but you can at least do some processing and reduce unnecessary information to protect privacy on the edge. In this use case, they explain about how to go about implementing this kind of technology. So previously I talked about like vehicle detection and then cropping the image and sending it to further processing. So you can build these individual capabilities into mediators. So depending on the sensor. So it could be water flow sensor, electric, video cameras, motion. So each of these sensors has the ability to reveal privacy sensitive information. So the idea is that for each of these sensors, you pre-build some of the components that make sure that when the data goes through that component, it will do some kind of analytics or alteration to that data stream in such a way that the privacy violations could be minimized. For example, let's say you have a component that will do the face blurring. So the camera data streams will go through this face blurring mediator, and then it will blur the faces. And then whatever the image coming out does not have faces, or faces are blurred. So then it reduces the potential privacy risks. So similarly, same idea could be implemented for different domains, different sensors, or applications as multiple data streams coming together. So if you can figure it out, what are the ways that you can implement these privacy protecting features, you can combine them into generic mediators, and then the data flows through will do some kind of data alteration to reduce privacy risk. This is a technique or idea to help the software developers or system developers to make better privacy-aware applications. So the idea is to have these mediators a little bit more generic rather than everyone developing mediators for every new application. If someone develop a face blurrer, maybe perhaps everyone can else use it. So maybe have like kind of like app store for a privacy mediator store, where software developers or system designers can download these pre-built components and put them in the applications to reduce any known privacy risks. Probably you remember that in a previous security section, we talked about top 10 security vulnerabilities. Here, over the next few slides, I'll be going to the OWASP top 10 privacy risks. However, it is worth noting that these privacy risks are identified not necessarily within the IoT context, but generally in the web domain. First privacy risk is web application vulnerabilities. One of the examples is that code injection or SQL code injection. We previously discussed that if you don't validate a particular input, and then if malicious parties submit a particular SQL query rather than type in their name or something, then it could reveal the information in your databases or any kind of data storages, which could lead to privacy violations. So SQL code injection is one of the vulnerabilities, but there could be many other vulnerabilities that leads to reveal the information in such a way that they lead to privacy violations. The second privacy risk is operator-sided data leakage. For example, if you are not managing access control in sufficient details, unauthorized people could access to your data. Or if you are storing data in plain text without encrypting, anyone have access to the storage could see the data in plain text. Or maybe you are unnecessarily copying some data to different storages or different places without knowing who should access to the data. So all these kind of issues broadly considered as operator-sided data leakages. Third privacy risk is insufficient data breach responses. This could happen when a particular data breach happens. The data owners, perhaps in IoT scenarios, IoT product owners, does not get informed about the data breach on time, so they can take measures. For example, if they are using the same username password, they could have changed it quickly if they get the notification earlier. Or even they could be more eyes open or more vigilant if they were informed that the particular data breach happened. So if someone is trying to reset your password or trying to access your emails, you could have take precautionary measures like enabling two-factor authentication or other similar techniques. Another privacy risk is insufficient delete of personal data. As mentioned even within the GDPR, once you finish the task you initially intended to achieve, you are supposed to delete the data. However, if you keep the data, then if a breach happens, then you are exposing the data that more than you ideally you should. For example, if you have an activity tracking system, you first need to determine what is the reasonable amount of length that you need to keep the data, and then after that you need to delete them, because otherwise the damage of a particular data breach could be much higher if you keep a lot of data. Another key issue in terms of privacy within IoT as well as mobile applications is non-transparent policies, terms and conditions. So you probably have seen large booklets of terms and conditions which nobody actually reads. And this becomes a problem in IoT as well, which IoT has more tendency to collect personal information than any other domain like desktop, web or mobile. So if you are not clear about what is the exact policy, where the data is stored, how long, where do you send the data, what kind of information you are deriving, what kind of sensors you are using, what kind of people are you going to share the data with. So all these information need to be transparently shared with the product owners or the end users. But more often we don't see this happening. And this is one of the main privacy risks in IoT. Collecting data that is not required to achieve the primary task is prohibited within the GDPR European privacy law. It is not something that you should do. You should first determine what is the types of the data you need to collect in order to achieve the primary task. Then you need to inform it to the product owners or end users and get the explicit consent, and then do as you promised. You should not use data for secondary purposes. If you really want to, you should acquire the consent at a second time if you want to use it for a different purpose. So the initial consent is valid only for the primary purpose. But we often see that companies first get the consent to do certain tasks, and then after that they do secondary processing without getting the explicit consent from the data owners. As a company or the manufacturer or the developer of an IoT system, when you share the data with third parties, it creates a significant privacy risk. This doesn't mean that you should not or you should never share data with third parties, but you need to be very clear and upfront with the end users, saying that what kind of third parties are you going to hire, what kind of services are they going to provide for you, under what conditions, and give the details as much as possible about the processing happens within the third party. And make sure you are conveying the specific rules and regulations that you want your third parties to comply with. Because at the end of the day, in privacy law such as GDPR, you are responsible for any violations that might happen by third parties. Another privacy risk is outdated personal data. For example, some of the personal information such as email addresses and phone numbers may be abandoned by the end users after some time. But if you are still keeping those kind of data, and then if the malicious party want to reset the password or thing like that, you will be probably using those old information to help reset the passwords and usernames. The problem becomes that because these particular information are outdated, the malicious parties might have already access to those leftover email addresses and maybe phone numbers. So when you legitimately allow them to reset the information, reset notifications would go to the old email, and then that could lead to a whole bunch of privacy violations. Missing or insufficient session expiration is another key issue. Basically, if someone is forgot to sign off or left the computer without signing off, malicious parties actually could get access to it. You should expire the session within a certain number of minutes, especially if there are inaction by the end user. So because the end user may be busy or their attention may have been focused on somewhere else, depending on the task they are doing at a particular time. Maybe it is in the mobile, so they keep the mobile and then went to do something else. So you should always try to detect what the users are doing, and if you feel like the users are not focusing on a particular task, you should expire the session to protect the account and the privacy of the end user. The final privacy risk is insecure data transfer. This is quite common in IoT, where we have dealing with resource-constrained devices. Sometimes the communication between two devices or two nodes, or even the node and the cloud, are not encrypted, or within the devices, the communication may not be encrypted. So insecure data transmission could help to leak the information for and make vulnerable for man-in-the-middle attacks. And also sometimes open ports also contributed to the insecure data management and communication. So you should also always consider encrypting the data when you are communicating between the IoT components.